In this video, we're looking at adding and subtracting rational expressions. So the thing we have to be comfortable with is adding and subtracting just fractions. So we have to remember that when we're adding two fractions together, we have to have a common denominator. So in the first example, if we look at the bottom, we have the same denominator, so this makes it really easy. So we're combining these into one fraction with the common denominator. So we have this numerator plus this numerator. So we can just go ahead and write that out. So 3x minus 4 plus 2x plus 5 on top, and we have that, remember, all over the common denominator of x plus 3. So now we can go ahead and combine like terms on top. So 3x, 2x would be 5x, and then negative 4 and 5 makes it 1. That's all over x plus 3. And remember, we have an undefined value at x equals negative 3. So remember, whatever makes the denominator 0. So we learned that when we were multiplying and dividing rationals. So next one, we have a common denominator already, so that's good. So now we can just put it over common denominator. We're going to be subtracting this numerator from this numerator. So 2x minus 1. So we can put a minus and then parentheses in our numerator in the second fraction, or we can just carry the negative through right now. So we have negative 4x and minus 4. So I just carried it through to all the terms in this numerator. So now 2x minus 4x gives us a negative 2x. Negative 1 minus 4 is negative 5. All over x plus 1. And x cannot equal negative 1. So it's undefined at x equals negative 1. So before we wrote this, we said x cannot equal negative 1. Just know that this and this mean the same thing. All right, next one we have, same deal. We have common denominator. We're subtracting the fractions, so we're taking this numerator minus this numerator. So 3x squared minus 2x squared would be an x squared. We don't have an x term, so we're subtracting a negative 3x, so we're actually adding 3x. And then negative 5 minus negative 2, so negative 5 plus 2 would be negative 3. All right. So undefined at, we can set that equal to 0 and solve for x. But we would see that x cannot be 1/3. Okay. So now let's look at least common multiple or least common denominator. So find least common multiple of each set of polynomials. So 6xy, 15x squared, and 9xy to the 4th. So least common. All right. So we need to figure out what 6, 15, and 9 least common multiple would be. So let's go ahead and factor these out. Okay. So we have 3 times 2 times y. That's this one. And then 15, we know that's 3 and 5. 3 times 5. And then x times x. And then this one would be 3 times 3 times x times y, so 4 y's. Okay, now some of you are going to be able to skip this step, but for right now, let's just write them all out. And then when we come up with the least common multiple, what we're going to do is we're going to look for something that shows up in all of them. So we have a 3 that are, so we're going to write that one time. Okay, and then a 2, we're going to write that because it doesn't appear in any of them. A 5, and then this other 3 here. So we have all of these numbers. So we wrote the 3 that they all had one time, and then the 2, the 5, and the 3 they all had, okay, each different number. So now we have an x that shows up in all of them, so let's cross it all off and write x one time. We have a y that shows up in 2 of them. Okay. And then we have to write the rest of the y's and the rest of the x's. So now when we multiply this together, we're going to get that x squared here. We're going to get this y to the 4th. And we're going to get 10 times 9. So 90. So 90x squared y to the 4th is going to be the least common multiple. Now we look at this. Okay, now we're going to have to factor this first. So we have, anytime we have terms, instead of just single terms, multiple terms, we have to factor out first. So this one, y squared, can come out. So we're left with that. And then we keep factoring because we can factor this here. So we have y plus 3 times y plus 5. This one we have to factor out. We have y so factors of negative 40 that add up to negative 3. So we should have negative 8 and positive 5. Actually, I'm going to drop these down. Oops. So now what we're doing is we're looking, what do they have in common? They have a y plus 5 in common, so we go ahead and write that one time down here. And then we're going to write everything else that shows up in each one. So we have a y squared that shows up over here. We have a y plus 3. And we have a y minus 8. So this would be the least common multiple of these two polynomials. Now we could multiply this all together. You guys can go ahead and do that. I'm just going to leave it like this for right now. Okay. So if it wants it in simplest form later, we'll just multiply that. I know you guys know how to do that. All right. So let's take a look at a couple more. So simplify each expression and identify any x values for which the expression is undefined. So remember what we're doing here, least common denominator. We're trying to list out the least common multiple that we just did in example 2. So least common multiple, and really we could do, it doesn't have to be the least common denominator, we could do the greatest common denominator or any denominator, any common denominator. But to keep it simple, we just have the 2 and the 5 doesn't have a common coefficient. So what we're going to do is multiply those together. So common denominator would be 10, and then x shows up in both of them, so we just have x. And we could write a little expression over here that we did in example 2. We could say least common multiple here. Well, they both share an x, so that's going to go there. And then the 5 and the 2, it'd be 2 times 5, so we just have the 10. So that's where we get this. So if they shared any kind of coefficients, we wouldn't have to write those multiple times. And then we need to think about what are we doing to this denominator to make it 10x. So we have to multiply this by 5 on the top and the bottom. Okay. So that gets multiplied by 5, becomes 10x, and then this multiplies by 5 and becomes 15y. And then what does the 5x have to get multiplied by to become 10x? Well, we have to multiply by 2 on the top and the bottom. So 2z times 2 would be 4z. And now we can combine like terms if there are any. In this case, there are not. So now we have to say, what can x not equal? Well, if we set 10x equal to 0 and solve for x, we would get us 0. So well, I guess we can put this down at the bottom. Undefined at x equals 0. Now this one, we have to do a little bit of factoring here. We have to pull common factor out. So 5 comes out and we get k minus 2 on this one. So if we notice these two denominators, the only difference is this 5 out here. So when we write this as a common denominator, we don't have to do anything to this top as far as multiplying because this is the common denominator. So we can just write this up here. And we cannot factor this, so we're just going to write it. K squared plus 16. Now this fraction, we have to multiply by 5 to get it to match down here. So 4 times 5 is 20, and we are subtracting fractions, so that's going to be a negative 20. Okay, so when we put these together, we get k squared minus 4 all over the 5 times k minus 2. And then we have to be really careful here. We have to, anytime we combine fractions at the end, we have to look to see if we can simplify any further. So k squared minus 4 can be factored out to be k minus 2 times k plus 2. And that's all over 5 times k minus 2. That's a k. And then we see here that we can cancel out the k minus 2's and get k plus 2 all over 5. So we remember back to multiplying two rationals together. Anytime we cancel anything out, that creates something special, which we'll talk about later. So k minus 2 actually has to be set as something that would make it undefined. So k cannot equal 2, because that would cause this to be 0. Okay? So that's what we have to write there. So don't forget about the ones we cross off. So we could start from the very beginning and just put all of your factors for the least common denominator as undefined values. Alright, so this one, top can't be factored, this can't be factored, this can't be factored, but this one can. So let's go ahead and write that out. We have x plus 2 times x plus 1. And then the only difference between these two denominators, this one has x plus 2. So that's going to be our least common denominator. Okay. So nothing happened to this fraction because this is the common denominator, so we just write the top. This one we have to multiply by this x plus 2. To make it match. Okay. So we're adding on this multiplied out, so we're adding an x squared, and we're adding a 2x. Some combined like terms on the top. We have x squared plus x minus 1. No, it's plus 3x. All over the bottom. So we look here first. Can this be factored out? The answer is no. So we're just going to go ahead and write the bottom. We're going to multiply that back out. So x squared plus 3x plus 2. And this is our answer here, simplified. And it's undefined at these two values from our common denominator. So undefined at x equals 2, or negative 2, and x is negative 1.